What a biosignature on Mars teaches us about water life and sipping. Last year, NASA's Perseverance rover collected a rock sample nicknamed Sapphire Canyon from a site called Cheyava Falls in Mars's Jezero crater, part of an ancient riverbed marked by the now dry channels of what was once flowing water. The sample revealed leopard spots of minerals, vivianite and greigite, alongside organic carbon, sulfur, phosphorus, and iron compounds. These elements, especially when found in clay and silt-rich sedimentary rocks, are known on Earth to preserve signs of life. Though this is not proof of life on Mars, it's perhaps the most compelling biosignature candidate discovered to date. Why this discovery matters. 1. Water equals story. Urgency. Jezero crater was once fed by rivers. The presence of sedimentary rocks and minerals that form in wet environments suggests that Mars had long watered periods. As we sip water here on Earth, we seldom think of its transience. On Mars, every drop, past or present, shapes the possibility of life. Studying Mars' water history challenges us to appreciate water as not just taste or refreshment, but as potential cradle of life. 2. Biosignatures and evidence. Finding minerals like vivianite and greigite in reaction fronts, areas where chemicals meet and react, is important because on Earth such minerals are often associated with biological processes. But those minerals can also form abiotically, that is, without life. Scientists must rule out non-biological explanations, heat, acidity, chemistry alone, before making claims. It's the same humility we preach in beverage studies. Tasting is never just about what might be, but about knowing what we don't yet know. NASA 3. Time and preservation. Clay and silt are excellent preservers of biology because their fine particles protect organic remains from radiation, oxidation, and weathering. The fact that the rover found young sedimentary rocks with potentially preserved organics means that Mars may have been habitable for longer, or more recently, than some previous models assumed. It pushes back the timeline. NASA. What we can learn as beverage and water lovers. This Mars finding connects surprisingly well to what SIP Studies cares about. Preservation matters. Just as certain soils preserve life, certain waters, mineral springs, aquifers, hold histories, traces of environment, microbes, time. When we drink or study water, part of what we're doing is tasting, or could be tasting, that story. Signals and noise. In life detection, there's a big risk of false positives, confusing abiotic chemistry with biology. In tasting, we also risk being misled. Sensory bias, marketing that oversells purity or heritage. It's vital to ask what evidence underlies what we are told or taste. Humility in discovery. Science on Mars is uncertain. We celebrate potential, but know the process, peer review, replication, alternate hypotheses matters. In wine and water tasting, similar humility helps us appreciate nuance without making unjustified claims about what we remember, what we smell, or what quality is. Looking forward. If this biosignature is confirmed, it could reshape our understanding of where life can exist and under what conditions. For SIP Studies, it's more than an astronomy story. It's a reminder that water plus chemistry, environment plus time equals possibility. Whether on Mars or Earth, that formula is central to everything we do. So here's the SIP question for you. If we ever tasted Mars's water or similar preserved extraterrestrial water, what might we notice? What stories do you think would rise in our glass?